Hello scholars, today we're going to talk about properties of numbers. And this is sort of how we can operate on numbers, what rules we can use, what patterns there are, and all of these rules and patterns, of course, we'll be able to extend when we're talking about operating with algebraic expressions, right? So a lot of this will be review from middle school, so we can go through it fairly quickly. So a very important rule is the distributive law, right? So it's basically saying that if, for example, we're multiplying 5 times the product or the sum of 7 plus 2, it's the same as, right? If we multiplied 5 times 7 plus 5 times 2, right? And we can check that. 5 times 7 is 35, 5 times 2 is 10, 35 plus 10 equals 45. And indeed, if we didn't distribute, and then first we added, right, 7 plus 2, we used our PEMDAS, right, for example, this would have just been 5 times 9, which does indeed equal 45, so we are all good. Okay, so this is a distributive property. Later on, we'll be using an extension of the distributive property to multiply binomials, right? When you see x plus 3 times x minus 4, and we say, oh, what did we learn how to do? Oh, there's something to FOIL. My teacher said something about foiling. No, don't memorize foiling or anything like this. All we're doing is we're distributing, right? We're distributing in the same way we distributed up here. We will be distributing the x to each term of those terms and the 3 to each term, okay? So anyway, this will be later, so we don't have to worry about it right now, but this is where we're going to see the distributive law later on when we get into some algebraic manipulation. Okay, then there's the commutative law. Commutative law says that, here, I'll just write it down here. If I have negative 3 times 4, for example, it's the same thing as if I have 4 times negative 3. In other words, it doesn't matter what order I multiply things, the product is going to be the same. And this may seem self-evident, it may seem very intuitive, right? In fact, negative 12 does equal negative 12, of course. However, later on, when you guys are learning about linear algebra, for example, you'll notice that when you multiply two matrices, in fact, matrices are not commutative when you multiply them, right? And in fact, we don't even have to go into matrices. We can ask, is every operation commutative? Well, it's certainly not, right? Because 5 minus 2, if it was commutative, I would say is the same as 2 minus 5. And is 5 minus 2 the same as 2? No, of course not. Of course, these are different things, right? So not all operations are commutative, where the order doesn't matter. However, good rule is that multiplication is commutative and also addition is commutative, right? It doesn't matter what order we add things. And that'll get us up to the associative law. So associative law basically says that if we're adding or multiplying, we can do it in any order we like. So 7 plus 3 plus 5, right? Of course, 3 plus 5 is 8, 7 plus 8 is 15, so we know what the answer is already, but this is just saying that I don't have to add in that order. I could in fact add in the order of 7 plus 3 first, and then add 5, which would be 10 plus 5, which of course would also be 15 as well, right? So this right here is an example of the associative law. So this is sometimes useful when we're doing mental arithmetic. For example, we like to add tens because it's easier to add things to 10 than it is to add things to 7 or 8. So let's take a look at an example that will allow us to sort of apply some of these rules by rewriting integers in different forms. Okay. Example number 1. Rewrite the integer 132 in the form of a minus b times a plus c. What the heck does all that mean? Well, basically, we're saying we want to decompose. Is another way of rewriting is another way of saying we want to decompose this number 132 and write it with a bunch of parts, right? So the first step is I see that we want to write 132 in the form of, right? We could say in the form of a product. I see that nice big multiplication sign, okay? So I say, well, 132 is what times what? Okay, well, we know our multiplication tables, so we know it's 11 times 12. And now I'm looking at 11, right? And I can say, how could I rewrite 11 as some number minus another number, a minus b? You say, well, there's many different ways I could do that. There's an infinite number of ways that I could do that. I could write 12 minus 1. I could write 13 minus 2. I could write 111 minus 100. right? You can see there's an infinite number of possibilities for a minus b, so let's just choose one. Let's do 13 and 2, okay? 13 minus 2. So I know that 13 minus 2 is 11, which is what I wanted. So 13 minus 2 times, and now I gotta be a little careful because you see how there's an a here and there's an a here. So when we use the same letter, right, in algebra, it means it's gotta be the same number. So if I put a 13 here to represent a, I better put a 13 over here. And if I put a 13 here, my c value now is fixed, right? Because I need to add something to 13, right? So I need to add something to 13, and the result has got to be 12, because I need to get to 12. And so what do I add to 13 in order to get to 12? Well, we add the value -1. So in this case, rewriting the integer 132 in this form, we could say that this is, if we write it in this form, the a is equal to 13, b is equal to 2, and in this case, c is equal to -1. And if you took those numbers and you plugged it in this formula, right, and then you did the addition, subtraction, multiplication, you would end up with 132. Okay, let's take a look at a couple more examples. So in this example, we're just being asked to represent a real-world situation using numbers, using arithmetic, and eventually we'll be using algebra as well. So write an expression to represent the following situation, and I'm going to write the expression as we read through the problem. You have $55 in your wallet, so my starting value is $55. There it is. You get paid $9.50 per hour. Well, getting paid means money. Increase of money. I'm getting money. So I'm going to put a plus sign because I'm getting paid that much. And $9.50, I'm going to write it as 9.5, $9.50. That's fine. So this is how much I'm getting paid per hour. And you worked for 3 hours last week and 7 hours this week. Now I could write this as, right, 3 hours plus 7 hours, right? In other words, 3 hours last week, 7 hours this week. And if I'm getting paid this much every hour, right, in order to calculate how much total I would get paid, we're talking about multiplication there. So I'm just going to use parentheses as multiplication. So you could write it as in this way and use the distributive property, right? Or you could just say, well, 3 and 7 is 10, right? So how about instead of 3 hours, 7 hours, let's just do 10 hours, right? So that's fine. That's actually a quicker way of doing this particular problem. Then what happens? Then your friend Theo borrows some money. So Theo borrows $80. So borrowing means take away. So Theo borrows $80. So we have this expression to represent this situation. And we can actually do all of this in mental math, right? So 55 plus, well, 9.5 times 10 is just 95. That's so nice, right? So I have 55 plus 95 minus 80. 55 plus 95 is 150 minus 80. So you have left about $70, okay? So that's how much you have left. However, if you wanted to write an expression, right, it would be this up here, 55 plus 9.5 times 3 plus 7 minus 80. Okay, let's do one more example. Example number 3, simplify the following, and we're given a few things to simplify. So it's really important to be able to operate with negative values, so be able to add, subtract, multiply, and divide with negative numbers. Later on, when we get into algebraic expressions, we're going to get into some more complicated, more difficult things, and we don't want to get tripped up by if I see a negative sign, oh no, now I'm really panicking here. I'm not sure what to do, right? We don't want to drop negatives. We don't want them to be on our paper one moment and then all of a sudden disappear on the next line. We want to be careful and thoughtful about them. So this is, I'll be very quickly. We can go over these. So 5 times -4 and positive times a negative is the same thing, or it will yield a negative value. So that'll be -20, okay? -5 times -4. Okay, that's going to be +20. So a negative times a negative is equal to a positive, right? The enemy of my enemy is my friend. It's one way of thinking about it, okay? 5 minus -4, okay? Well, if I'm subtracting a negative value, it's the same thing as adding a positive value. So this is actually just going to be equal to 9, okay? And if we want to make sense of this, one way of making sense of this is, let's think of this negative 4 right here. Let's think of that as debt. So if I have negative $4, let's say, right? This is my debt. I owe someone $4, right? I'm in the hole for $4. The first $4 I make, I gotta give it away. It's as if I didn't make anything, okay? So this is debt. So what would it be, what would it mean if I took away my debt? If I took away this debt that I owed, right? Well, I'll tell you exactly what it would mean. It would be as if I had just gotten an extra $4 because I do not have to pay $4, right? If I remove debt, it's as if I'm up $4, and that's why negative, right? Negative 4 is the same thing as positive 4. Really what we're doing here, another way of thinking about it, is we're distributing the negative, right? We can think about it algebraically. Negative times negative is positive, okay? So I can just also, another way I can think about it is I'm distributing this negative, which is really just a negative 1, right? When there are lots of hidden ones in front of numbers, right? Hidden coefficients of 1 in front of numbers. Okay, let's do 2 more really quickly. So negative 5 minus negative 4, well, we just saw that this is the same thing as negative 5 plus positive 4, and negative 5 plus 4 is negative 1. You can either reason about it by using the number line, right? If I start at negative 5 and I add 4, right? Adding is going in this direction, I end up to be negative 1. Or you can just reason with it a bunch of different ways, right? That's fine. Or use a calculator, that's okay. And let's do the last one, negative 5 times 4 minus 5. Okay, I could do this one of 2 ways. I could use the distributive property, which would give me negative 20 plus 25. You can check that over, which is just equal to 5. Or if I wanted to, I could actually do negative 5 times, well, 4 minus 5 is just negative 1. And negative 5 times negative 1 is also equal to 5. And I'll be darned, you get the same answer because math is consistent. So that is great. Have a good week.